All right. So as usual, I am going to post this. Oops. Post this on iTunes. Post this on iTunes. Wow, I sound a million years old. On Twitter. Gonna post it on Twitter. And I'm gonna post it in my stories. So give me a second. Let's see. Oh yeah, I should need to close that. Need to get rid of that. All right, here we go. Thanks for joining me. Tonight is going to be a quick stream. I am trying to get in the habit of doing this, trying to get to a point where I can reliably make things look and sound good without it being a whole production. And also experimenting with how to make a computer go fast enough. I wanted to start by showing the current progress of Valentine in the middle of rebuilding the UI. And this will be a way of grounding the purpose of the hacking around I want to do in C Major. So let's grab some loops. Of course, I don't have them ready. Yeah, whatever. I'll just grab something from drum loop, full drum loop. Sure. Oh, need to move my phone. Okay, here we go. And I remember to look at my phone actually because cool. So that's Valentine. Need to remember to look at my phone because that's how I kind of plan on monitoring comments right now because I haven't gotten things, totally slickly set up. So just need to find the link. Here we go. Great. So yeah, here's Valentine. Once again, you see the very heavy CPU usage. That is because my computer is operating at about 30% capacity because it's tired. So, wow. So if we can get the UI to do something, right? It's a compressor. Sounds cool. I think it sounds cool. But it also has, I'll turn the saturation off. Yeah, so it has this crush effect that is a combination of downsampling and bit crushing. Where is it? And the way we do the downsampling, actually this is called, actually, I forgot, I think during my last stream I said this wasn't a zero order hold. I think it is. I think I mixed up sample and hold and zero order hold. Hold up. Da, da, da. So let's see. So if I remember correctly, I'm going to stop trying to look stuff up and just go with it. And if you see this and you'd like to correct me, please do. Zero order hold, essentially every sampling interval will grab something from our input buffer and copy it over to the output buffer. And then any sample between that, we will replace it with a 0. And as I said during the last stream, the notes aren't here. I'll show them later. That's pretty easy to implement for an integral downsampling rate, but it's a little trickier to do, especially for an effect with a non-integer sampling rate. Now, I've done something incredibly jank here where I simply do the zero order hold for 2 adjacent samples and interpolate between them. It kind of sounds cool, but I think it could sound cooler, which is why we're here. Let's see. So at the end of the last stream, I pseudocoded out something that would be the beginning of a replacement. Let me waiting for Obsidian to start up. Because, okay. So that nicer method is outlined here. Big shout out to Signalsmith Audio for not only having posted this on KVR forums, but also explaining things to me so I understood them enough to confidently try implementing it in front of people. So the idea here is that we use an oscillator, right? We use an impulse train that is going to be implemented a whole lot like an oscillator in order to generate the aliasing that we want. We're going to use a band limited impulse train because even though we are creating aliasing on purpose, we I'm gonna go let the cat out. Hold on. All right. So, and this is well explained in this paper, but essentially, if you naively create any oscillator, it's going to create a bunch of harmonics. And as I was very loosely explaining during the last stream, right, in a digital system, right, you can only capture a certain bandwidth of frequencies. We call it the Nyquist frequency, and that's going to be half of the sample rate, right? So if you are sampling at 44.1 kilohertz, you can only record samples of frequency between 0 and 22-ish kilohertz. Once you get above that, you start getting what we call aliasing. And so you might say, part of the issue is, right, is even if you have, even if your signal is, of the proper bandwidth, nonlinear processing like a compressor or a distortion, of course, distortions are the big ones, will create, they sound cool because they create harmonics. They create additional signal that's above what was in the original source. Some of those are going to be above the Nyquist frequency, and they are going to then fold down into the audible range as aliasing, and it doesn't sound great. And the same is true of oscillators. And this kind of specific kind of oscillator is a band-limited impulse train that is specifically designed to, as you can see here, let's see. I think I understand this. We can relate the number of harmonics. So M here, right? So we basically generate a sync signal, with M being the number of harmonics that we want to generate, right? And the thing is, we limit the number, band limited, the number of harmonics here based on the sampling rate, P being the sampling period, the inverse of the sample rate. So we're using that band limited impulse train because we want the cool aliasing that we want, and not uncontrolled aliasing that is, there because I guess you could just do it with a naive like Dirac delta, like for the given interval, for a given interval, once the interval's elapsed, the signal is 1, and every other moment it's 0. That'd be I think that's a Dirac pulse. Anyway, but you're not here, and I'm not really here for DSP, so I'm gonna surf on out of there, and I suppose get to what do we have to do to start implementing this. What's the smallest step we can get to something that builds? So, because there's a lot of unknowns here, let's take a look at the examples. Nope, that's not the examples. Use some example patches. Yes, I do trust the Cited. Okay, cool. Yeah. Let's take a look at this. Unless it's just, oh, well, that doesn't really help us because it just uses the processor node to frequency. I know this is a huge file. I'm not going to try to look at that. That's going to be, you know what? Let's go look at the documentation, because the first question that I have, well, first off, you know what? Let's start with something that builds. And also, let's start with something that we can change the volume of. I guess we can node gain equals, is it smoothed gain? Let's just copy paste that. Because I don't want whatever the result is here to be blasting this in the ears. That's going to be extremely unpleasant. So our first iteration of, can we just get this to build, will be, also let me make sure that I'm actually thinking about this correctly. Because the gain is a node. Yeah. Okay. Up gain dot in, and then up gain dot. I'm not sure if I have to specify. Yes, well, I did this time. And right, so let's start with this. Let's, I don't know, just like basically, I wanted to start inaudible. Also, let's be a little tidier. Let's see what's going on. Okay. So we've got this hypothetical effect, and I am going to strip out basically everything I think that is going to make this not build, and then slowly, because there's a lot of stuff at once in here, right? And I feel like it's definitely not going to build right away. And if I how do I put it? Hold on 1 second. If I try running this before I've got kind of a baseline of what builds and what doesn't, it's going to be a pain. So let's not do that. All right. And let's just close these. Let's get that, just in case. Let's get that Cmajor plugin going. Okay, cool. Now you just give me 1 second. Okay, so good news is that it builds. The one issue is that it actually shouldn't be on, and I guess it doesn't really matter, but since it's not being read as an instrument, probably because it's a generator and not an instrument. I don't know. That's something that I'll have to look up later. But anyway, so currently we have something that builds. Great. So now let's see. Let's start introducing things. So let's do it in order of, let's see, this sync depends on a bunch. Trying to think of the dependency order. You know, CalcM, it might be your, and I have a feeling I'm gonna have to look at the documentation. Yeah. Maybe just need to do, oh, this is, I think, gonna be an integer. Do you like that? Oh, of course. Of course. Let's see. Is it called stood floor? No. Okay. Time to look at some documentation. Felt like okay, that's a bit annoying. Floor. Oh, it doesn't know what is P? It is the sampling period. And do we need P for anything else? I don't think we do. So, well, I mean, at least we don't need to store it. We do need M. So, frequency. So whenever the frequency changes here, we get the sampling period. We calculate the number of harmonics. We get this ratio between the number of harmonics and the sampling period. And then we set the frequency of our phase counter. You know, I'm going to set that aside and see what. Oh, obviously this needs, oops, a type. Oh, and it still doesn't know what this is. Oh, can I just say floor? Cannot find the symbol. Oh yeah, of course. Oh yeah, how do we find out about the sampling rate? Okay. Maybe now the examples. Create a new batch. No. View some example batches. Huh. Dare I look at the Pro 54? Yeah, why not? Sample. Ah, okay. Processor dot frequency. What is processor here? Is this like a special? Okay. Oh, let's see. Frequency. That is not what I would have called that. Awesome. Okay. I guess it's only mentioned 8 times. It's not that big of a deal. But this, I have a feeling that I'm kind of barking up the wrong. Actually, I'm not. Am I allowed to do this? Oh, okay. Yeah. I can do this. Interesting. Okay. So I guess I think that's no, that is not how you declare a 64-bit float. Let's see. Literals. Oh, okay. So I think it's no, it's not that. Oh, it's just float 64. I am really overthinking that. So oh, I see. Is this like auto? Yes, it is. Can I do that? No, I probably did that wrong. So let's not get fancy. And let's just, okay. So I need to, how do I cast this? Can I just do, oops, C style cast? Nope, I cannot do that. How do you cast? Oh, casts. I see. float 6 is not a thing. Oh, okay. No, I misunderstood the issue here. So, let's see. What is the most correct place to put this cast? Let's just say here. You know, I guess there's no reason. I have a feeling that having calc m output int is going to be more trouble than it's worth. So, float 64. I wonder if that's going to be an issue. You know what? It might be an issue. So actually, I'm going to go back on that. I think m or whatever is supposed to be an integer. So let's int. No. So int 32. Oh no. Here we go. Int 32. Oop. 32. Int. Does it matter? No, whatever. Can always change it afterwards. Event handler. Yes. Oh. Okay. Cool. So that's progress. I'm gonna double check to make sure that the channel's muted. Yes, it is. Okay, cool. Now let's see what's up with this phaser state stuff. Cannot find symbol phaser state. Okay, that's not a good sign. Let's see, standard library. I have a feeling that this is not actually a thing. Or maybe, am I misspell? Oh. Well, it could be. That could be the issue. Okay. So okay. I'm going to go ahead. Assuming the terminal's going to load for me, which seems like maybe it's not going to happen. There we go. I have a lot of Git stuff to do. Yeah. Yeah. We don't have Clang format yet. So there's some ugliness staying in here. Okay. So what do we have now? We should define this calc sync function. And let me try, because I think my life actually is going to be easier if I figure out how to do the generic sample type. Let's see, how is it generally done in the Clipper? So could I do using sample type X? No, maybe not. Fine. I have a feeling that I made the wrong decision here. I should have just demoted the frequency to, let this become just a 32-bit float, but you know what? For now, let's just go with this. I don't know. You know what? I am not going to think about epsilon. I'm just going to go. This is, as I pointed out, so this is the main function, and this is kind of like an exit condition, or I don't know what you call that, escape condition. This is what you do when otherwise the system would become unstable, malformed, something like that, because of a divide by 0. That's what I got from. Did I put that McGill paper? It'll be in the description. Anyway, so basically, given x, given the input, if x is approaching 0, we're going to do this other version of the calculation. But otherwise, we're going to do the normal sync calculation. And let's see how it likes that. Okay, still building. Okay. In that case, oh, okay, let's see. Cannot determine the type of value. Let's see, MP is a float 64. Why? Oh, because the outstream is, that's probably why. Flow 64. Cannot determine the type of the value. Oh. Cannot. Do I have to explicitly reference the output? Oh. My goodness, I keep. Okay. So hypothetically, oh, this should make some kind of noise. It is not, so clearly something has gone wrong. And that's okay. I actually need to end it just about here because I have something to do. But you know, oh, wait. No, I mean, I didn't put an input parameter in for frequency, but that should be fine because it should initialize it at 440, which should be totally audible. So I think you know what? Let's expose input BLIT dot frequency Oh, okay. Well, yeah, as you can see, so, you know, that happens sometimes. I'm going to make sure that that's nice and muted before we tear this down. I think I do this frequently. Yeah. All right. So, yeah, so far I'm still happy. I'm pretty happy with the fact that I think I got pretty quickly to a place where at least I knew that I had messed something up. Um, and obviously that gets us a bit closer to uh actually doing it correctly. Oh, at least I hope so. But anyway, thank you for joining me tonight. Not sure when I'm gonna do this again. Probably this weekend, but I'll announce it on Twitter. Yeah, have a great night, and see y'all later.